Microplastics, they're a real problem in our water system. So I'm about to meet Weiter, who's going to tell us all about how to take those microplastics out using a very advanced filtration system. Here at the University of Luxembourg, there's a lot of research into making water clean, many different approaches. Tell me about your approach.
Well, my approach is to develop a filter which has an affinity for microplastic. With this commercial filter elements, which are today on the market, you filter it out all other particles too. Then the filter is directly blocked.
So there are tiny particles of plastic in our water.
Yes.
How do they get there?
There are different ways. So we call it primary and secondary microplastics. Primary microplastics are already small produced, for example, for cleaning things in your house or for makeup and so on. And in makeup is also really small plastic particles in it. And when you wash your face, then it comes directly into the water system. The other part, these secondary microplastic particles, you wash your clothes and it's a polyester pullover, then through your washing machine it goes also to sewage treatment plants.
Because you often see in the news that, water bottles are weathered and broken into smaller pieces.
Exactly, yeah.
But this is not microplastics, or not just one source of microplastics. Microplastics are actually entering our water system in ways that we hadn't thought. I mean, I've never actually thought about wheels and friction and particles from wheels entering our systems.
Yeah, here is a sample with microplastic particles in it. This sample is from the effluent. So it's the cleaned water after the sewage treatment plant, which goes into the lake or
this goes
somewhere
into our water, people.
Laura explained to me that microparticles come in a range of different sizes, from the big to the so small that your eyes can't even see them. And it's this tiny size of microparticle that Laura's research is most concerned with.
Normally filters work like this, that when you have smaller particles, then the pore size is. So the particles are smaller than the mean flow pore size of the filter media, then all the particles go through. When we put now the modified layer and put the microplastic particles on it, and the microplastic particles are smaller than the mean flow pore size of this element, then the microplastic particles stuck on the modified media.
That is cool.
We have a relationship between a fiber in the main layer and the particle, and they stuck together. So usually a filter element looks like this. These different layers here, what you can see here are 5 different layers, are normally covered about the whole element. This one is closer to the pure side. The dirt water comes from the outside, go through all these layers and come here out as pure cleaned water.
I mean, it's an exciting technology. One burning question I have is someone going to have to go around changing the filters when too much is stuck onto the surface?
It will take a while.
What's the future of your research? Where is this all heading?
The challenge is the size of the particles, because you can take the bottle and it's out. But when you go smaller and smaller and smaller, that it's more difficult to filter it out, these microplastic particles, then you need always more energy to filter that water where microplastic is in.
And you may be filtering out things that you want in.
Exactly. You filter it out everything and not only the worst part. So I go into the field, I go to the sewage treatment plants, I make my field test, and I really work on it, not only in lab, also in field, and to see which effect it will have. Directly through a sewage treatment plant comes the water from householding, from industrial, from
street drains,
ambulance, street drains, exactly. So it's a really central point. The good thing is when we can solve the problem with all these challenged amount of other contaminations, then we can also filter it out microplastic in other applications.
Thank you so much for explaining it so beautifully, and good luck with your research, and I can't wait to see this in practice, because when you see the size of the particles and the fact that it's all around us, we really need your technology. So thank you.
Thanks a lot.